Welcome to my channel Max Soccer. Yesterday I had given introduction to principle of mathematical induction, and I had given introduction to algorithms, means steps of solving problems. Today in this session we are going to do some of the problems based on mathematical induction. Here one problem such that prove the following by using principle of mathematical induction for all n belongs to n, that is 1 cube plus 2 cube plus so on to n cube, that is equal to n square into n plus 1 whole square by 4. For solving this problem we use three major steps, that is base case, inductive hypothesis and inductive step. First we take the base case. In this, let P of n be the statement that 1 cube plus 2 cube plus so on to n cube, that is equal to n square into n plus 1 whole square by 4. We will prove this statement by mathematical induction. For the base case, we have to test this statement by taking n is equal to 1. Therefore, left hand side becomes 1 cube is equal to 1. The right hand side of the equation is 1 square into 1 plus 1 whole square by 4, that is equal to 1 into 2 square by 4, that is equal to 4 by 4, that is equal to 1. From the previous step we move to the inductive hypothesis, that is assumption step. Assume that the statement is true for some positive integer k. This means we assume that 1 cube plus 2 cube so on to k cube, that is equal to k square into k plus 1 whole square by 4. After this step we move to the inductive step. We must now prove that the statement is also true for n is equal to k plus 1. That is, we must prove 1 cube plus k cube plus 2 cube so on to 1 cube plus 2 cube so on to k cube plus k plus 1 whole cube, that is equal to k plus 1 whole square into k plus 1 plus 1 whole square by 4, that is equal to k plus 1 whole square by 2 into k plus 2 whole square by 4. Starting with left hand side of the equation, for n is equal to k plus 1. From the previous slide we have 1 cube plus 2 cube plus so on to k cube plus k plus 1 whole cube. Using our inductive hypothesis, we can substitute the sum of the first k cubes, that is k square into k plus 1 whole square by 4 plus k plus 1 whole cube. Now we factor out the common term, that is k plus 1 whole square. If we take k plus 1 whole square common, we left with k square by 4 plus k plus 1. To combine the terms inside the parenthesis, we can find the common denominator, that is k plus 1 whole square by k plus 1 whole square into k square by 4 plus 4 into k plus 1 by 4, that is k plus 1 whole square into k square plus 4k plus 4 by 4. This is the expression in the numerator and is a perfect square trinomial, that is k square plus 4k plus 4, that is equal to k plus 2 whole square. From the previous slide, we have k plus 1 whole square into k plus 2 whole square by 4 is equal to k plus 1 whole square into k plus 2 whole square by 4. This matches the right hand side of the equation we wanted to prove for n is equal to k plus 1. Since the statement is true for n is equal to k plus 1, whenever it is true for n is equal to k, by the principle of mathematical induction, the statement is true for all positive integers n. Thus, in the answer, by proof by mathematical induction shows that the formula 1 cube plus 2 cube plus so on to n cube is equal to n square into n plus 1 whole square by 4, and it is true for all positive integers n. So, I will conclude this session. If you have any doubt in this session regarding to this problem, you put comment in the comment box. I will try to rectify the same. And those who are not watching the video, I will put the link in the description box so that you can see the video.